Alright, so today we are graphing a rational function. Our function today is x squared minus 5x plus 6 over x squared minus 9. First step is to factor, so the quadratic on the numerators is going to factor to negative 2x minus 3, and then on the denominator we have negative 3, positive 3 from the difference of squares. We can see here that these are going to cross out, leaving us with x minus 2 and x plus 3. Since we cross those out, that's going to create a hole, and the hole is going to be at with the mental switch x equals 3. So to determine our full coordinate set in for y, we're going to get, it's going to be minus 2 plus 3, sub in 3. So we'll get 3 minus 2 over 3 plus 3, which is going to give us 1 over 6. So our full coordinate for our hole is 3 and 1, 6. Vertical asymptote we need to solve. We just use the denominator from our simplified function, or from which is just going to give us negative 3 with a mental switch. For our horizontal asymptote, it's a little bit more complicated. We need to set x close to infinity, but first we divide every value here by x squared. So when we do that, we do the division, we're left with 1 over 1 because these just turn into 1, and then 5 over x plus 6 over x squared minus 9 over x squared. Since on the bottom it's going to be close to infinity, those will just all cancel out to 0. And we're left with 1 over 1, which is just 1. For our intercepts, we need to solve our y-intercept first. We'll set x to equal 0. Anything times 0 is 0, so we're left with 6 over negative 9, which is going to be negative 2 over 3. For our x-intercept, we set y to equal 0. And then to solve that, we need to get rid of the denominator here, so x squared minus 9. We'll multiply that by that. When we times it by 0, though, it's just going to equal 0, so we're just left with this quadratic, which we've already factored from up here, so we'll have negative 3 and negative 2, but this is a whole, so we cannot use it. And then our x-intercept is going to be 2. Next we need to determine our end behaviors for our graph, as well as just some more points. So from our vertical asymptote, we had negative 3, so I set negative 2.99 and negative 3.01. When we sub those into our function, we're going to get a very negative number, which tells us that when it's on this side of the asymptote, it's going to be negative, and then the opposite when it's on the right side, or sorry, the left side of the function, it's going to be very positive, so up here. For the horizontal asymptote, when it's positive 1,000, which will be way over on the right, we're going to get a number just below the asymptote, so it's going to be here. On the other side, it's just going to be just above. And these are just some more points that I subbed in to solve to make our graph more accurate. Now with all the calculations that we've done, we have enough information to sketch our graph. So with our asymptotes, our vertical one being at negative 3, our horizontal at 1. We have our intercepts. The y-intercept is at negative 2/3, and our x-intercept is at 2, right here. Our hole is at 3 and 1/6, which is going to be right here, so I have that marked. And then some other points that we have are just right here, and those are on our graph. We determined our end behaviors, so we know it's going to be going up here, down here, and above over here and below here. So now it's just a matter of connecting kind of through our points and sketching our graph. So going through here, we got to come through our points, come through, cross the y-axis and the x-axis, we go to the hole, stop, and then continue on the other side all the way through. And then over here, we start up here, come through this point, down, right to the end. And there you have it. That is our sketched rational function.